Hi there, I hope everybody is doing great. It's been some time. I have made some videos. Actually, it's been hectic. So today I have come up with a video where I have been sent an email with the model by one of the subscribers, and it says I have modeled a hollow sphere made of foam material. I have applied a radial displacement to the inner surface, but when I run my model, I receive the following error. Whenever a translational degree of freedom at a node, so the subscriber has given this error, which is about degree of freedom 2 on some 2 of the nodes. So we have to check what this error is. You will find my abacus.inp file attached. So the user has not sent the CAE file, which I can modify in terms of geometry or mesh, but the user has sent me an input file, which means it's already meshed. All the boundary conditions are already applied, so I will have to import this as a model. So I will show you that as well in the start. Could you help me resolve this issue? Thank you in advance for assistance. So let's jump into it. Okay, so let's first import the model which was sent to me. So you need to click on INP files. The file, you see I have removed the brackets. And now it should do that. So this is the foam material which the user has mentioned, and the user says that, let's see what this is. So you can see there's only one part here, which is this one, and if I look at the part, then it's an orphan mesh, so I can't see much on that from that perspective as well. Anyways, this is already meshed because it's an input file, so I don't see the geometrical features. Material properties I can definitely see. So material is called material 1 here, and it is in HyperFoam material with some material parameters which are used here, 1, -2, and 0.25. Again, I'm not going to check the correctness of that. Most probably the subscriber have or some kind of reference to these properties. Then the solid section part, and this is a solid homogeneous section with material 1 properties, and then this has to be assigned to this part. So if I click on this, then you see it is assigned to it as material 1 to this whole geometry. So assignment looks okay. Then we go to assembly. Obviously assembly is just the part here. I can see there's a reference point here as well, but we will look into it later on. So then step, and the step is, as you can see, is a static general step, and it's non-linear geometric option is on. Total time, maximum number of increment is 200. You can always use a larger value, as I always recommend. Initial time increment is 0.0015 and the maximum is 0.05. Total time is 1, so for that simulation. So this looks okay to me. There shouldn't be any interaction, but okay, in this case, as I said, there is a reference point, so most probably some kind of coupling constraint has been used, but let's see. So if I click on constraint, then you can see there is a coupling constraint here, and in this case it is a kinematic coupling where all the degrees of freedom of this surface are constrained with this reference point here. This reference point could have been stored there as well, but again, it depends on the user what they want. So whatever is happening to this reference point will also happen to these nodes at this surface. Okay, so this looks fine. Anything else? I don't see any other options. Then I go to the loads, and if I can zoom out, so we can see that there is no force applied, but there is boundary condition. So you see here on the vertical surface, it's been used as X symmetric. So and this one is Y symmetric on this edge. Because if it's X symmetric, then U1 should be 0. No, I think it's fine. And in this case, U2 is 0. So that's fine. This is Y symmetric and this is X symmetric. So that looks okay. Then there is a displacement boundary condition with a displacement of U 1, which is in one direction, and that is 36.292. Again, I don't know the units, so I'm just assuming, and it's a ramp, so it will increase linearly, as you see here on this reference point, which is constrained with all of these things. Okay. Then there is another boundary condition, and this is basically U2 is 0, and I think the third one should be the UR3 to be 0. Okay, so all looks fine. This is Y symmetric, this is X symmetric, and then this is constrained with this, and it can only move in this direction, no rotation, nothing. So that's fine. Then we go to the mesh and check what element type they have used. So if I click on this and I click on that, then you can see they have used axisymmetric stress elements. So this means it's spherical. I think user said it's a spherical foam. So this would mean that it is going in this. But again, I think if you have modeled this way, then it's not actually axisymmetric. It's more like a cylinder, because you have X symmetric here and Y symmetric here. So again, I'm confused with the modeling here. But let's go with the axisymmetric, quadratic, standard elements they have used. No other thing, everything is default. So because this, normally when you use axisymmetric elements, then you have to start modeling it with axisymmetric as well. So there you have already a symmetry here, and then this means it will rotate about that and about that. I think it should be fine, because if it is axisymmetric here, this means the same thing is on the other side, and it's the same on the other side as well. I'm not sure. Or maybe model 1/8 of the sphere if you really want to model like this. So let's go and see what problems he is facing first. So again, I don't know the exact case, so I'm just going with that. So I'm gonna create a job through it. Let's call it hollow sphere 1. Rename it, and then I go to precision as double full precision, and I press OK, and then I submit. So when you submit, press monitor, so I don't see any problem. It's running fine, as you can see. There are some issues with the convergence, but that could be due to the loading or material parameters used. Yep, so it doesn't finish, and you can see the minimum time required is specified. And if we go to the start of this thing, message file, warnings, then you see there are numerical similarities when processing all these nodes, right? There are quite a lot of warnings and a lot of negatives. So most probably your material properties are not correct. So if I go to visualize results to see what's happening, so you see what is happening is your material, or you have two components here maybe, that is causing this problem. So you see your boundary conditions are working fine, but you have a lot of distortion on this face because all these nodes are not constrained, so the displacement is very high. So second thing is, I think in the assembly you have two components here. So if you go to the assembly here, then you will see you have two instances, part 1 and part 2. So I think one of them you can suppress, and because this is extra part, I think by mistake you might have done that. And then for the dimensions, I think you can check the dimensions as well. And if I can press this from here to this point in X direction, distance in x direction is 7 millimeters, right? And if I measure the same from here to here, then that's also 192 millimeters, and the displacement you're applying is 36. So obviously it's a lot of deformation you are having right now. So when I run it, so if I try again, so boundary conditions are not there. Okay, so I think we need to suppress the first part, not this one. So resume and suppress. Then let's see what happens. Submit and submit it. So I think the first part, so you applied the boundary condition on the second part, not on the first part. And that's why we got that warning. Two nodes have degree of freedom incorrectly boundary condition. In this, okay. System has, I think your material properties might be the problem here. And that could be because it's again we're going to the same point and then it gets stuck. But you see that numerical singularity thing is gone because of the fact that we have removed the other geometry, because that was moving around everywhere and there was no constraint to it. So, but these negative eigenvalues are generally because of the poor mesh or due to the material properties. So now but I don't see that error which you are mentioning. So I'm not sure. 2 degrees of freedom two nodes have a degree of freedom with incorrect boundary condition. So this is basically because of the fact that you have x-symmetric and y-symmetric boundary condition, and also you have this constraint. So the node which is common for both the boundary condition, which is this one and this one, is struggling, and then what ABAQUS does, it removes all the constraints from it. So it only applies the one which is last one. So most probably it's applying only the displacement, and that's what you see here. When you apply this, then you see it's moving in this direction and it's all fixed. So you see this node and this node are not constrained in this and in this direction along this axis, but they are moving around as you see here. Exactly, that's what's happening. And then obviously your mesh is distorting, so you're getting those problems. So you might have to work around with the mesh, and obviously this is a pretty large deformation as well. So I hope this makes sense and you can give it a try. You can refine the mesh in this area. You can reduce the boundary conditions and play around with the mesh so that you get the converged results. Also double check your material properties as well. It could be just because of the material properties, which can give you these negative eigenvalues. So mesh you have to check. These constraints you have to check because currently you are applying constraint on this point as y-symmetric, x-symmetric, and also you are constraining it with the reference point. So this common node has 2 constraints, and ABAQUS applies the last one, which is the boundary condition one. So hence the other one is removed, and that's why it just keeps on moving around. I think that's what is happening. So MPC is still active. So have a look and see what it wants. If you want help, I think if I were you, I would try to model it as 1/4 or 1/8 of a sphere, and then it will be easier to deal with all these problems. Okay, so if you have any question, then get back to me and I will definitely try to answer those. Thank you very much and bye for now.